Good morning, good afternoon from wherever you are around the world. Welcome to today's webinar. I'm AJ, but I'd like to introduce our speaker today. Friend to the program, Ivan. Hey, Ivan. And new to the program, we have Pramod and David. Hey, David. Hey, Pramod. Thank you guys for joining us today.
You bet.
Excellent. Before we get
Thanks,
started,
AJ.
we do have a few housekeeping items we'd like to cover. First, if you have any questions, please submit them using the Ask a Question tab below. We'll do our best to answer all of your questions live. And no question is too wild. So if you have anything you'd like to ask, submit them in. We'd look forward to answering them. I see David's eyes there, so I'm sure he's looking forward to any question you send over. And in addition, we know that you guys are here to hear from us, but if you have any feedback, let us know how we did, how we're doing, or what you'd like to hear at future events by hitting the Rate This tab also below the presentation screen. Without further ado, let's hand this off to today's speakers. Team?
All right, great. So I'll kick us off. Hi, everybody. I'm David McIntyre from Samsung. I lead product planning and strategic initiatives. And the reason I'm here today is because one of my favorite strategic initiatives is going to be presented to you today. We're going to talk to you about optimizing data architecture with Samsung SSD Value Kit, SVK, and VMware Greenplum, the awesome database offered up by Greenplum. So just some quick legal disclaimers. This presentation should be taken as is. There's no warranties or implied items here that you may need to consider. So just please review this content and consider it as an opportunity to be educated. There's no specific claims made during this presentation. So moving ahead from the legal disclaimer, let's get into our presentation. So first of all, why VMware and Samsung? Well, VMware is excellent at software, virtual machines, software-based solutions, and Samsung, amongst other things, is excellent through device technologies, including solid-state drives and memory. And so we decided, why not put our heads together and collaborate on an initiative that will enable the VMware Greenplum customer community and ecosystem with better performance and better total cost of ownership through Samsung technologies. So by providing a cost-effective, highest performance Greenplum database reference platform, we're able to offer that and show that to you today. So VMware is delivering as part of the solution the Greenplum database version 6 release. They're defining the platform configuration, which you'll learn about more from Pramod. And then also they will provide the education services on this reference platform so that it can best benefit the solutions that you require in your own applications. And then what Samsung delivers is, as I mentioned earlier, the hardware best-in-class performance configuration that is certified by the VMware Greenplum database standard. So by having this tight integration and partnership with VMware, we will be able to tune our hardware to specifically to provide the best performance and cost advantage to our customers, to you, the Greenplum customers, in partnering with VMware. And more specifically, so Samsung has offered up the PM1743 PCI Express Gen 5 solid state drives with significant performance benefits over previous generations. And we'll give you more information on that shortly. And also the SSD Value Kit, the SVK, which features many feature enhancements, including power efficiency throttling and RAID. So this collaboration provides the very best TCO benefit to Greenplum and customers such as yourself. So with that, I'll pass that over to my very esteemed colleague, Ivan Novick, who leads product management across the Greenplum team over at VMware.
Thanks, David. Let's go forward to the next slide. Are you seeing it there now?
You're there. Yep, motivation.
Okay. Yeah, I've got a little bit of a slow connection here, so I'm off video. And actually, I can't see the slide, so I'll have to go on memory. But essentially, the question here is, what's the motivation for us coming together and partnering on this solution? And looking at the key points behind this project is that the customers and the enterprises out there today are doing more and more with data on a daily and annual basis. They have more data coming from more locations and have more use cases that they want to use to impact their business. And the reality is, when it comes to data storage and data computation, is that it really makes a huge difference what technology you use. Because the data sizes are so large, the impact for your selection of hardware can be monumental. And because of that, it's really important to care what hardware you use and to have an opinion and a sense of what's good when it comes to hardware in order to get data storage and data computation that can really rock and really make the performance that your business requires. Now, as a backdrop for that, since the last 10 to 20 years, we've seen a 100x performance improvement in individual drives. So if you were back in let's say 2010, a lot of hard drives were running at 100 megabytes per second of I/O, and we're looking at drives now that are 100 times faster with 10 gigabytes per second in one drive. So it's crazy fast, and drives have always been the rate limitation when it comes to big data processing, right? The drives are always slower than the speed of the memory and the CPU, and that's why a lot of database designs have been made to deal with the fact that drives are slow. But now with massively fast drives like these drives from Samsung, the game is changing. Now with Greenplum, you can completely customize the solution. You can modify the hardware. You can build solutions based on hardware, and that's why this customizability is really popular and exciting, because we can see as this new hardware comes out and we can put it together and build amazing solutions. So together, our idea is, let's do something really impactful. Let's build a world-class solution for data warehousing and for analytics and for big data. And I think that's what Promote is going to show you today, is really world-class performance when it comes to data warehousing performance. And the whole point of this is to let customers and users to do more, to get more done, and not to get more done by spending more money, but because the technology is smarter and faster, that they can do it. And we're providing that template, that pathway that we've tested, that people can follow with our white paper, which we'll show at the end, that you can download and use that to follow along and not have to really experiment, but to see how we did it, so you can just copy. Okay, so now talking about the use cases and where this comes in. Obviously we're here with Samsung, which makes you think about factories and manufacturing. Factories are becoming smart factories. Cities are becoming smart cities. We work with a lot of stock exchange and trading firms that are looking to expand their data sets, continually as trading volumes increase. Utility and energy companies producing power or delivering power to end users and doing smart metering. Police and militaries around the world, travel companies, transport and logistics, e-commerce and retail. All of these enterprises, really, it matters that you have the super high performance solution that can manage big data. So that's why this is all coming together and why we're proud to show this solution together with Samsung. So with that, let's turn it over to Promote to jump into the solution.
Hey everyone, can you guys hear me?
Yep, we hear you.
Okay, all right, thanks everyone. Hey, my name is Pramod. I am Director of Engineering here in Samsung Semiconductors. I work from San Jose. So it has been, first of all, I just want to make sure that I say a big thanks to everyone who has worked on this joint collaboration. There has been a lot of collaboration effort across VMware and Samsung to do this. So first of all, thanks to everyone who has worked on that. We have, as Ivan and David were saying, that we have a Greenplum, which is really a massively parallel database. So you can imagine, like, you have a F1 driver. So how do you provide the best car in the world so that you get the performance from both the sides? So it starts with finding out what are the key requirements. So you can see on the left of the slide. So this is the Greenplum architecture. It's a distributed architecture. You can see a master host sitting on the top, and it is talking to all the segment hosts. And so we started with the analysis that, okay, what are the key enabling areas where the system, from the system side, we can enable the full power of Greenplum. And we have listed out few of those items on the right side. You can see it as a key system requirements. So what we have observed is that it starts with the data loading itself. Once you have a very large data, the master host picks up that data and starts distributing across all the hosts. And it's all a heavy data write operation. So loading is going to be really a throughput sensitive operation. We could understand that. And then when the query is executed, there is a lot of segment instances inside the segment host, which are like the logical partitions, right? And then these logical partitions, they talk to each other within the device and across the nodes also. So we could understand that, okay, there is a lot of data transfer going on. Again, it is a throughput and maybe IOPS sensitive operation. And then there is segment instance mirrors also, which is part of the Greenplum architecture. And those are, again, across the host, right? So whenever you write the data, if your mirroring is enabled, which is the default case, you keep on transferring the data. Again, all these things are very, very throughput sensitive operations. So our first priority was, let's tackle throughput. So if you can really increase the throughput, you can see your F1 driver going much more faster. Other than that, what are the things which we have to look at? The data resiliencies. Oh, of course, at the application level, you get the mirror segments, but if you want to have the data resiliency at node level, you need to have some solution for that. Of course, it has to be performant and not hit your dollars. So that was another thing which we actually take a note of that. What was the other thing? It was the power. So we want to make sure that while you're actually increasing the performance, you just want to make sure that, it don't hit on your wallet again. So reduce the operational cost. And of course, the final one was a IOPS. So it's a database. So this application is going to be IOPS sensitive, right? So these were the key things as, our notes from our side to enable Greenplum from the system side. So now let's move forward. Let's see what we have. Okay, let's move. Oh, sorry. So here you can see what we say it as a Samsung SSD value kit. So you have hardware, and part of the effort which we put is that how we make sure that the hardwares or whatever we put it at the system level, you can add more value to that. It can be in the form of, say, something like the rate. So whatever rate services you have, you just want to make sure that it is tuned in a way which is more compliant to your application workload. So we came up with this value kit, which say it as Samsung value kit. It's an umbrella term where you have many features which is intended to do the same thing, increase the value add of your underlying storage. And one of the things which we tried here was SSD optimized RAID. It's a software RAID. I'm going to talk a little bit more on that in the coming slide. You can see what we found out. But essentially, the SVK is an umbrella term. It's a framework, and it is actually intended not only to provide you the best performance with the reduced TCO, it's also intended to make sure that it is having an easy path of adoption. So what we have done is that all this SVK framework is built on top of a common framework, which is a REST-based framework, and it can talk to the backend of any of the software-defined storage, just like APIs, right? There's no direct particular storage-specific commands you have to run. These are API-based. And it can also, since it is REST-based API, you can actually directly control from your application as well. So it's up to you. How do you want to use it? The other thing which we wanted to make sure is that these APIs should be manageable and configurable as per the customer needs. So you can see here in the diagram below, the blue boxes from the down, the bottommost layer, you can see the SSD, the FTP enabled SSDs, CXL SSDs, and high capacity SSDs. And on top of that is where the SVK software layer sits. You can consider it like a library, right? And as of now, we have the RAID being tested on Greenplum as a workload. We have other things to follow up, which is cluster power optimization. It's a way where you can actually tune the power as per your application workload. So you don't have to spend more power, right? So we provide all the APIs how to do that. We also have other services which are coming up, like zero ETL services. You can imagine just like the application where you want to have a near storage compute. So this framework is going to help you for that. So it's coming in future. And you have QLC services. Again, it's in the roadmap. It's going to come under the same framework. So from the application side, you will be getting the APIs to access all these features. Okay, let's move forward. All right, so the core of the whole solution is the Gen 5 enabled SSDs. So this is the first offering from Samsung side on Gen 5 SSD. You can see that this is the first industry first 16-channel NVMe enabled SSD. We have some power numbers to discuss, and you can actually see that how it reflects on the power. And it's being tested on the generative AI servers. That's what we are testing internally. It supports the hardware encryption. It's multi-tenant compliant device. It's ready for mass production. And as I go forward, you will see that how it translates in the TCO benefit. On the right bottom corner, you can see the specs of this particular device. So this is a E3.S by 4 device. And you can see the sequential read is 14 gigabytes per second. Sequential write is 6. Random read
this is the spec for just a single drive, correct?
This is the spec for single drive. That is right.
Very good.
Yeah. And the random write is 180K IOPS. So this is available in public, and the data sheet is also available. So in case anyone wants more details on this device, we can definitely share more on this. Right, let's move forward. All right, so we used a base server architecture for the whole exercise, right? And you can see on your left half side that how this server looked like. So the highlighting point here is that apart from the Gen 5 SSDs we have, it's a single socket machine. And the processor we have used is AMD Genova CPU, EPYC 955 854P. It had 48 core. With hyperthreading, it is 96 cores. We had 4 by 100 gig network interface for this server. We used 512 GB of RAM here. And in our experiment, we used 8 drives. This system can take in 16 drives. You can see on your right side that it can take in 16 drives. So in our experiment, we used 8 drives. And with 8 drives, you can see the sequential read was clocking around 116 gigabytes per second, which is almost 2 times the nearest, the best performing Gen 4 SSD. And sequential write was again clocking around 50 Gbps, again 1.5 times better than Gen 4. Random read, 18 million IOPS, and random write was 2.3 million IOPS. Again, you can see on the basis we have actually compared it with the best performing Gen 4 SSD, and it's on the read it is always 2 times better at least, and then on the right side it is 1.5 times. A quick overview on the server itself. You can see that it's a single socket, so it had 24 DIMM slots. It has 12 memory channels, and another thing to note here is that it's a 1U. The rack space is going to be just 1U, so it's a very slim device, right? So it's save on your space also. Right. Moving forward. Yeah. So this is a quick software stack view of one of the single node. We have tried to explain how does it look like when the Samsung system software goes beneath the Greenplum architecture, right? So you can see on the bottom, that's where you have the SVK features as well as the Samsung SSDs coming in, and the upper portion of the stack is not at all touched. So so somebody who is installing the Greenplum, you just follow our instructions. It's going to be seamless installation of SVK and the SSDs also. I just tried to list out a few of the advantages again here. So this is going to be a Gen 5 SSD. So of course you have increased throughput, which reflects in your TCO benefit. With Gen 5, you can do the work much more quicker. So of course, it reflects on your power bills also. We have some data to prove that. The SVK rate is going to be a software rate, but don't worry, I think it's not going to hit on the CPU. We have data to prove that. It's coming in the following slide. And the thing to be noted here is that what we have done is that, of course, we have partnered with third party to get the software rate for you. But what we have done is that on top of that, we have optimized the rate for the performance and based on the Greenplum workload, right? So we have optimized it. And we did some system level tuning so that you have the best performance coming out of Greenplum. And again, as I said, that the whole system is tuned from an application standpoint, an application workload. Right, moving forward. Okay, so this is the quick look at the benchmark test setup which we recently went through. So on the right column, the baseline Gen 4 column, that's our baseline system. What we have done is that we have chosen one of the popular Gen 4 machine. This is a Dell 7525 machine. And we have installed Greenplum 6.24 on that, and we have used the TPC-DS as our benchmarking tool. And whoever is familiar with TPC-DS, you will know that we have knobs to actually increase the load, increase the number of concurrent users, and those are all configurable items, right? So on the hardware front, the cluster configuration, what we used is one master and 4-segment host. And the Gen 4 CPU was a dual socket AMD CPU. And the Gen 5, which is the system which we are talking today, and the recommended one is just a single socket one. And you can see the number of cores and the amount of memory for the baseline Gen 4 machine is double as that of Gen 5. So Gen 4 is double that of Gen 5. So double the resources. And number of drives is exactly same, 32 drives, all 4 terabyte. So the total capacity is 128 terabyte. And the network connectivity is exactly same, 4 by 100 Gbps. And you can see the rack space there. So it's 2U for the baseline, and the recommended one is just 1U. Again, saving on the space side, right? So yeah, so this is just a quick overview. Let's move to the next slide.
But before we do, Pramod, we do have a question from the audience. So, you're showing some pretty impressive performance gains with the Gen 5 SSDs over Gen 4. How easy is it for a developer to adopt this new reference architecture that you're introducing to us with the Samsung SSD value software, the SVK? So, yeah, migrating to the higher performance environment, how is that straightforward, or what would you recommend?
Yeah, so as I mentioned that so the SVK is an optional service, so it adds to your value. So, but if someone just want to try out Gen 5 SSDs, it's just like you just plug it in and you install the driver. So you have instruction on the Samsung website how to do that, and you can just directly get access to the Gen 5 SSDs. Now coming to SVK, if you want to install SVK, we are still working on how we get this SVK deployed. But as I have spoken earlier, this is going to be a library which is downloadable from the Samsung website. Most likely, we have to still decide that where exactly we are going to host, but it would be hosted most likely from in the Samsung website, and then you can download this library. You can install this library, so all the instructions would be given, and we are going to have a SVK deployment framework as well, where you can just connect to the server. You say that, okay, what all SVK features you want to download, and you click, say, I want to download, say, SVK RAID. You just click it. The framework downloads it in one of the machine, which say is a admin node where you download it, and the framework takes care of distributing it and installing it across the cluster which you have configured. So we give you option that how you want to configure the cluster. So the installation is going to be at a cluster level. And once installed, it is going to run some basic tests just to make sure that the installation is complete. Now, once the deployment framework comes and says to you that, okay, the installation is complete, your software, the SVK software is ready for you to use. And we are going to put documentation saying that what are the APIs you have to use across for each features. So that's going to come in. We are right now working on that, defining those APIs. But from a application developer point of view, it's all going to be API based. You can say that, okay, say for power throttling, right? So you can just set your performance numbers using the APIs, and the SVK internally will just translate it to the corresponding optimal power on the drive. So it's all going to be API based. Yeah. I
can tell you're really excited. You're going into the meat of how to implement. That's great because you're living it today. Another question just came in, Pramod, on is the RAID level configurable?
That is right. You can configure RAID level. Yes, you can have RAID 5, RAID 6, whatever you want. Yeah.
You got
Those
it
are
all.
configurable
Okay.
items.
Super.
Yep.
Let's go to your next slide here.
And by the way, this is one of the first times I've ever seen software RAID that doesn't introduce a noticeable penalty, right?
He
That is
has a
right.
slide on this, Ivan. So
Okay.
We have slides.
good forward look.
Yeah.
All right.
Yeah. All right. So let's get to the meat of what we have found here. So in the slide, you can see that how the performance, what is the performance we have got. So on the left top graph, you can see the load time. So and on the y-axis, you can see what is the exact configuration you have used. We have used here, just to make it quicker, right? So what we have used for this is a configuration in TPC-DS, which simulates 15 concurrent users, and we have total of 32 segment instances across the cluster. And what we have noticed is one of the most time-consuming operation is loading the data. So here we have used a 3 terabyte of data, but you can go till 50 terabyte, and also the loading becomes really the pain point, because that without loading you cannot do anything else, right? So that is one of the time-consuming thing. And what we have observed, exactly the same configuration between the baseline Gen 4 machine and the recommended Gen 5 machine. We could quickly see that the load time just reduces to half. And as you can see in the graph, that it's 54%, which where we can see that, yeah, with Gen 5, you get 54% better loading time. And then we proceeded with the performance run, and you can see the score. So the TPC-DS gives you the score, which accounts for loading time, the single user query execution time, and multi-user query execution time. So it is a combination of all the 3 factors, which reflects in your score. And the score, the higher the score is, better for you. And you can see with the 15 concurrent users, we can quickly see that, yeah, it is 40% or more than 40% better in performance compared to your Gen 4, the nearest Gen 4 best performing machine. Also, a thing to note, we just took a note of what is the data loading rate, and we found that, it can load 15 terabyte per hour, and I think that's probably more than double.
15 terabytes an hour is for 4 segment servers, right?
Yes.
Four machines,
4
right?
segments.
So if we extrapolate it out to like a full rack, we would probably be putting, because they're only 1 U, you could probably put like 30 or 40 machines in a rack.
Yeah.
Right. So you're looking at 150 terabytes an hour for a rack.
That is right.
Okay.
That is right. Yeah. And so we did a lot of different combination of our test configuration, and we could always see that it's always, the performance always is more than 10% at least. On the notes section, second from the bottom, it describes the machine which we have used as our reference machine. It's a SMC machine, and I have put in the model number also in the notes, second from bottom. So you can see that what are the machines which we have used for our benchmarking. Right. Let's move on to the next one. Can you go back? Yeah. All right. Let's go to the next slide. No, you can move, AJ. Yeah. So how it is reflecting on the power. So what we did is that we tried to take to the worst case, or the worst case scenario for our testing, which is like just to be apples to apples, right? We kind of reduced the number of cores and memory of the Gen 5 baseline machine to just make sure that it is exactly same as that of the recommended Gen 5 machine. So Gen 4 and Gen 5 with exactly the same number of cores and memory, we run the 50 terabyte test, which is a long haul test with 15 concurrent users, right? You can see it in the slide. And what we found out that the total energy consumed just dropped to 20%. Again, this is with 50 terabytes. As the data varies, you will see more performance benefit. Like if the data is more, you will see more benefit. But this is what we could run in our lab setup, and this reflected in 20% or more than 20% reduction in energy consumption. And this is, again, the setup is 4+1 node cluster, 4 segment host and 1 master, and each node could benefit 8 kilowatt hour per node with 8 drives, right? So this is, again, 8 drives in a node. So direct power, a lot of power saving directly. And this is with only Gen 5 coming in picture, right? So we did not have the power throttling numbers yet, so we are just still testing in our lab. But you can imagine that once the throttling also comes up, it will add to the saving which you are going to get on the power side.
So, Pramod, another question came in. If the capacities of these drives continue to increase, the Samsung drives, is there any performance considerations or concurrent query considerations or is this just, it's a great thing, it's higher capacity with less drives, providing a direct TCO benefit to the customer?
Yeah, there is no performance impact. So right now, I think these tests are done with 4 terabyte drives, but you also have 7.6 and 15.3 terabyte drives. All are having very, very similar performance numbers and power numbers. So I don't see any performance hits if you change the performance capacity. Oh, sorry, the capacity of the drives.
Okay.
There is a price difference on the size of the drives, but
yeah, the price is definitely a difference. Yeah.
So another question came in. So are these drives SED capable? TCG, Opal 2.0 compliant? Have we gotten there yet?
Are you referring to encryption?
Yeah.
So how do we handle encrypting of the drives, Pramod?
I have to take a look at that. Can I get back later on that?
Sure, absolutely. Yeah. This is a first look at this platform, so but that's an excellent question that we can address. It seems like there's from the viewpoint there's been some issues with the slides. Rest assured the audio is working as well, but just rest assured we're recording this session and we'll certainly share it out afterwards. So no concerns from the audience standpoint. Okay, are we ready to go to the next slide?
Yes, let's go to the next one.
Okay.
All right. So there was a question on the RAID. So this is our RAID performance testing, and this is again with 3 terabyte of data with exactly same, all other configuration exactly same. We have run the RAID against the no RAID, and you can see that in terms of performance, again, just to recall, right, the performance is a combination of loading, query execution, both in single user and the multi-user mode. The performance is just below 2% hit, and more importantly, when we try to see the CPU utilization, is again like it's almost the same. So we took a couple of readings. So all readings came, the performance per CPU utilization was always under 1%. So virtually there is no impact on the CPU. And so you use your software just like an installer, right? Just a software kit, and configure your RAID type, and you're all set with no impact on CPU. And the performance is very much near to no RAID itself.
And there's no RAID controller, no hardware.
There is no RAID controller. This is pure software solution. Right. So you can see it in the highlights. No need of hardware-based RAID. And it meets the performance, no CPU impact, and the throughput based core, right? It still remains under 2%. So that's what we have got in our RAID, right? Let's move to the next one. All right, so this is something which we have recently, there is a joint white paper which we have published. Ivan has brought up some information based on the previous Greenplum architectures, which we have used. And Ivan, you want to quickly take us through that?
Yeah, this is really comparing the current hardware to the data computing appliance, which it's been out, it's been no longer available for about 1 or 2 years, but the data computing appliance was doing something around 3 gigabytes a second per machine, right? So now at 120 gigabytes per second, it comes out, the actual detail, it comes out to 48 times faster, just in terms of pure ability to do I/O. And compared to the data computing appliance data loading, it's 10 times faster. But we didn't also consider that if this machine was a 1U instead of a 2U. So if you looked at it from a point of view of a rack, you're looking at 20 times faster loading per rack. And then the data warehouse benchmark, the TPC numbers, also multiple times faster.
Right.
Okay. So let's jump to
move. Yeah. So just to recall all the things which we have talked till now, right? So of course, the first thing was, of course, the performance and performance per CPU or the resource utilization, right? More importantly, we are always able to hit more than 10%. Again, 10% is a very conservative number here. We have seen like 40% and all at different test configurations. So, but this is the minimum for sure you are going to get. And 20% of power saving just because you have moved from the best performing Gen 4 drive to Gen 5 drive, right? So minimum of 20% you get. Again, we are not accounting for the extra power saving which comes with the SVK power optimization feature. This is just with Gen 5. And on the RAID side, since it is a pure software-based RAID, you're going to save your cost on the hardware RAID. So altogether, right, all the three components, as per our calculation, it is going to benefit at least 40% on your total cost of ownership for your Greenplum installation on this machine, right? And it's more than 5x times higher throughput compared to the legacy system, the slide we just actually went through, right? So one of the things which I just wanted to say here is that now the TPCDS benchmarking tool does not give you a direct number for the IOPS increment, but we have run these stats to see that how much IOPS you gain with respect to the Gen 4 machine. We saw that it is almost 1.86 times better than the Gen 4 cluster. So you are getting definitely a much higher IOPS also with this machine. That's pretty much from my side, I think. Yeah.
Okay.
David, you want to?
Yeah, I will. So Pramod, thank you very much for the very informative presentation. I would say that this is a really great opportunity for the audience here, and both live and that are watching the recording, to have a first look at this extremely exciting platform co-developed by VMware and Samsung together. So Pramod basically gave us a sneak peek on many of the features, both on the hardware technology, the PM1743 Gen 5 SSDs, the platform that we've co-defined and developed with VMware, and then also the SSD value kit, SVK, which, as Pramod explained, is a value add service that enhances the features beyond the hardware for power savings, for performance tuning, for power throttling, and many more exciting benefits to come in the very near future. So what I would say is click on that QR code and learn more by studying the white paper that is, the ink is pretty much still wet on that white paper. It was recently presented at VMware Explore. And so take a good study, a quick study at that, and then feel free to reach out to any one of us in this call, both at VMware and at Samsung, to learn more. So we just wanted to make sure that this community had the first look for as we start building our go-to-market planning around this reference architecture. So just a quick summary, 30% TCO advantage. I think Pramod even significantly suggested a higher TCO benefit. Working hand in hand, tightly coupled with VMware on Greenplum certification. So don't try and do this on your own, people. You have to work with Samsung and VMware to come up with the best performance, cost savings, and also power management advantage through this specifies platform. And, we showed that the performance benchmarks will significantly improve that cost performance ratio. And that's it. So I will pass it on to AJ to close us out. And thank you for everyone's attention. But AJ?
Excellent. Thank you, David. Thank you, Pramod. Thank you, Ivan, for today's presentation. Most of all, we'd all like to thank all of you guys for joining us today, whether you're watching this live, you're watching this in the future, hello from the past. Thank you guys for joining us today. As you see, David mentioned, there's a QR code here that you can snap a picture of and get access to the link. We've also included some links in the attachment section of this webinar as well, and that does include the white paper that we were just alluding to. So again, this has been recorded. I know there was someone that had commented on an issue of not being able to see the slides. This has been recorded and will be available on demand. The slides should be available there as well. But if you have any issues, you can email us directly and we can get maybe a version of the slide deck over to you as well. But again, thank you, Ivan. Thank you, Pramod. Thank you, David. It was a pleasure being able to work with you guys on this event, to listen and learn from you guys. And we're looking forward to maybe having you guys on in the future. So thank you all and have a great week.
Thanks a lot.
Okay, thank you.
Thank you.
Bye all.